Hey guys, today we're going to be going over the Pythagorean Theorem, which is actually just a really simple formula that we can use to find the missing side of a right triangle or of a triangle that has an angle that measures 90 degrees. Now, as I said before, the Pythagorean Theorem is a formula, and that formula is a squared plus b squared is equal to c squared. Now, in this formula, each of these variables, a, b, and c, they stand for one of the sides of your triangle. So, what's important to know is that the variable c is always going to stand for your hypotenuse, or the longest side of your right triangle. So we know that this variable c here can be used to represent this side right here. Now, a and b, these variables right here, are interchangeable. They can both represent one of these smaller sides. So a could represent 3 and b could represent the side measuring 4, or vice versa. It's just important to know that you're always going to have c as the hypotenuse of your triangle, or the longest side of your triangle. And the way we're going to find c using, or our missing side using the Pythagorean theorem, is we're going to plug in each of our sides and they're going to become one of our variables. So a could become this side right here measuring 3. So a could become 3. So now we have 3 squared in our equation instead of a squared. B could become 4, the side measuring 4. So now we have plus 4 squared instead of plus b squared. And we know that the hypotenuse is c. The hypotenuse is always c, the longest side. However, we don't know what c is, so c is going to stay as c squared. So now we have the formula 3 squared plus 4 squared is equal to c squared. Now, we can just keep solving. 3 squared is equal to 9, plus 4 squared is equal to 16. E is equal to c squared. C squared is staying the same. Now 9 plus 16 is equal to 25. So 25 is equal to c squared. Or in other words, c is equal to the square root of 25. And since the square root of 25 is equal to 5, we know that c is equal to 5. So this side right here is going to be equal to 5. Now, just as a quick review, we used our knowledge that of the Pythagorean theorem that one of the smaller sides squared plus another one of the smaller sides squared is going to equal the hypotenuse, or your longer side squared, so that we could plug in a as one of our sides 3, b as another one of our sides 4, and c as our hypotenuse, which we didn't know, so we kept it as c squared. We plugged in each of the length of our sides into the equation, and we could use our equation to find that c is equal to 5. So in this case, it was the hypotenuse that we didn't know how to find. But in some cases, we know what our c is, what our hypotenuse is, but we don't know what one of the smaller side lengths is. We don't know what either a is or either b is. So in that type of problem, which I'm going to show you how to solve in just a minute, we are going to plug in c and one of the smaller side lengths, and it's going to be either a or b, one of our smaller side lengths that we don't know that we are going to solve for. So in this case, we know what the length of one of our smaller side lengths is, and we know what the length of our largest side length, the hypotenuse, is. However, we don't know what the length of the second one of our smaller side lengths is, so we have to solve for the length of that. So we'll do the same thing as we did in the last problem. We'll plug in each side for a variable. But in this case, b squared is going to say unknown, since we don't know what the side length of b is. And we can plug in a squared and c squared into our equation. So a squared can become 5 squared, since 5 is now equal to a. We're making 5 equal to a. So a squared becomes 5 squared. And we don't know what b squared is, so we're just going to keep it unknown. 5 squared and b squared plus b squared. B squared is going to stay as b squared. However, in this case, we do know what the length of c is, the hypotenuse, so c squared can now become 13 squared. So now we can just solve the equation as we did last time. 5 squared is equal to 25. 25 plus b squared, which stays the same, is equal to 13 squared. Now 13 squared is 169. So now we have 25 plus b squared is equal to 169. And now to get b squared on its own on one side, we can subtract 25 from both sides. So now we have b squared is equal to 169 minus 25 for 144. Now b squared is equal to 144, or in other words, b is equal to the square root of 144. So b is going to be equal to 12. So I just wanted to show you another scenario in which we knew what the hypotenuse and what the smaller side length was, but we didn't know what the length of the second smaller side length was. So that's how you would do it in this case. Now, sometimes the answer you get right here, sometimes that cannot be square rooted evenly. Let's say I had a scenario in which b squared was equal to 145. So b squared is equal to 145. I would have to square root 145. However, 145 does not square root evenly. So in this case, when you don't get an even square root that square roots perfectly, you're just going to you can either do the decimal. I wouldn't recommend that. But most likely, your teacher will want you to put b is equal to the square root of 145. So in that case, your answer will just be a square root. So that's how you use the Pythagorean theorem to find the missing side of a triangle. Hope you enjoyed this video, and I hope to see you next time.